right? Because that was the only way that we knew how to graph a quadratic, was with a graphing calculator. Now we're going to talk about how do we actually graph a quadratic. Okay, and there are multiple ways and multiple approaches to graphing quadratics depending on what is being given to us. Okay? So, any type of quadratic. Okay, so a quadratic in general is a function that can be written. I think I've been fixing this every year for like 3 years. In the form y equals ax squared plus bx plus c, which is the same type of quadratic we have been looking at for forever. There are different ways that we can then manipulate those quadratics to get different pieces that are important for graphing. So guys, we're taking notes, headphones need to be out, off, put away. But regardless of what information is given to us, if we have something with an exponent of 2 that is a quadratic, its graph is always going to be a U-shaped graph that we call a parabola. Right, so we saw what those looked like when we pulled out the graphing calculators and we were looking for the x-intercepts. I think one of the most important thing to understand with graphing anything, okay, is that you don't have to have a bunch of rules memorized. My students struggle with this frequently. Okay, they always will say to me, well, how do I graph this line? I know it's a line, but how do I graph it? How do I graph this absolute value function? You do not have to have different rules memorized for each of those situations. Do those rules make it easier to graph? Yes. But do they keep you from graphing altogether? No. Because the one thing that we can always fall back on is that any time we are graphing, we can always make a table and plug values in. Now, the one flaw with making a table is that if you don't know what shape it's going to be, and you only make 2 points, 2 points always make a line, right? So if you stop with only 2 points, every graph you make is going to look like a line, which is not going to be correct. So if you're not sure what this is going to look like, make a longer table. Okay, even if that means you have to plug in -10, -9, -8, -7. I watch my students take state testing. They finish 20 minutes early and then they take a nap. And they just leave a problem like this blank. I'm like, what the heck? Just plug in a bunch of numbers. I mean, yes, it takes time, but literally, guys, when you take the I-step, you can have nothing else. Nothing. Like, your devices have to be in a separate room. You can have nothing. You kind of just sit and stare at a wall. So you might as well use the time to plug in some points. Now, I'm going to pick some specific points today because I know they will be helpful. You might have to be a little bit more precise in picking your points. Okay, so I'm telling you, let's plug in -2, -1, 0, 1, and 2. Why? Because I'm kind of focusing in the middle of the coordinate plane. Okay, then just like with any function, we can take these values and we can plug them in for x. So instead of now saying y equals x squared, I can say y equals -2 squared. How important are those parentheses? Very important. So -2 squared is what? 4. Then I'll do that process again. Except now I'll say negative 1 squared. What is negative 1 squared? 1. What is 0 squared?
0.
What is 1 squared? 2 squared?
4.
Okay. Once you make a table of values, those give you ordered pairs that fall on the graph. So hopefully, we remember from past years algebra. Okay, so hopefully remember from past years, right, we can put these as an ordered pair. Okay, so we can plot this as the ordered pair negative 2, comma 4. Okay, so to plot this point, we'd go negative 2, positive 4. Okay, then we'll plot the point, negative 1, comma 1. Zero, comma 0. One, comma 1. 2, comma 4. Now, just like with any function when we're graphing it, right, this is just a few points that represent it. It is not every point that represents it. Okay, we're going to fill in the rest of the points by then drawing the shape in. So what shape should this make?
A V.
No, what did we just say it should make?
U.
A U-shaped graph called a parabola. Right? Just like we saw. So we need to know, oops, that this is really going here. Right? It is continuing on. Right? We were just getting those 5 points to get the basic of the shape, and we're filling the rest of it in. You cannot just do straightforward connect the dots and draw harsh corners here. That's not what's happening. Okay, that is where you do have to have some basic information. Right? Quadratics make a U-shaped graph. Now, this next little section that we're going to do is going to feel really overwhelming for a minute. Graphing quadratics in the form that we're looking at today is one of the easiest topics for my students. They always do great at this way of graphing, but I have to give you a bunch of terms ahead of time that you've never heard before. So you're kind of like, what the heck is going on? It all comes together when we start graphing. Okay, so give me a minute to sort of go through and explain the pieces. Don't freak out too much when you're kind of like, okay, what does this mean? It'll all come together when we graph it. Okay? So there are parts of a quadratic, right? So remember in Algebra 1-1 where we learned about a slope and an x-intercept and a y-intercept and what it meant if it was positive slope and negative slope and those types of things? This is sort of what we're talking about right here. There are some characteristics of a quadratic. A quadratic has something called an axis of symmetry. Okay, it is the line that divides the parabola into 2 matching halves. So you have probably been doing this for forever, but you didn't know that you were ever actually dealing with an axis of symmetry. So way back when, starting in, I don't know, elementary school, and it got to Valentine's Day, and you wanted to make a heart, you took a piece of paper, you folded it in half, and then you did this. And what did we get when we opened up the paper? A heart, right? Why did we fold the paper in half to start with? So each side looked exactly the same, right? A heart is a symmetric object when we draw that line down the middle. One side is exactly the same as the other. That's what makes a heart look pretty. When one side doesn't look exactly the same as the other, then you get the whole wonky thing. You're like, oh, that's terrible. A parabola has the exact same thing happening. In the quadratic graph, in that the right-hand side is a mirror image of the other side. So if you were to fold that in half, one side would be exactly the same as the other. Okay? A quadratic also has a vertex. Well, graph of a quadratic. Okay? It is the maximum or the minimum point. Max or min, shorten it if you want. Okay, when we look at lines, lines go up and down in both directions for forever. Parabolas do not. They go both up or both down, which means there is a point on a parabola that we cannot either go any lower than or we cannot go any higher than. That is called our vertex. It's right in that middle fold. Okay, we will know if the graph has a maximum or a minimum by the point A. If A is greater than 0, then the graph will open up and the graph will have a minimum. It will have a low point. Okay, this is perfect. Yes?
So when you're using 1/4 of a graph, like the L shape, which one is the parabola? Like, is it going down or is it going up when you're using one of the chords for the graph?
Like, no. This says if A is greater than 0. What types of numbers are greater than 0?
1, 2, 3.
Positive numbers. So this says if A is a positive number, you will have a graph that opens like a bowl and you could pour water into it. The only A we are going to see today is positive 1. Okay? If A is less than 0, what types of numbers are less than 0? Negative 1 is the only one we are going to see today. Then the graph is going to look like a hill. Okay, so it's going to open down and the graph will have a maximum. So all of the functions, the quadratic functions we look at today, will still have an equal sign. We're just talking about whether or not that A value, right? On this quadratic, A had a 1, it was positive, so this would open up. Okay with those? Today, when we look at graphing quadratics, our quadratics are going to be given to us in this form. Right now, I just need you to trust me that quadratics can be in that form. Carson, like all the wheels on the floor. Oh, we can't send those chairs. That's why they're breaking. Okay, so when we look at this, we need to be in this form. For what we're working, like what we're looking at today to work, it needs to be in that form. Okay, if we are in this form, we will be able to find the axis of symmetry by having the formula x equals h. Okay, another word for the axis of symmetry is the line of symmetry. Sometimes you'll see it abbreviated as LOS. Okay, this literally says write down x equals, and then h is going to be the value inside the parentheses. Okay, if we want to find the vertex, it will be h comma k. Okay, so we can find the vertex, if we can find the axis of symmetry, and we know if the parabola is going to open up or down, that's all we're going to need today to be able to graph it. Okay, so if we can just identify a couple key features, we'll know the rest of what the graph looks like. Now, one thing we need to pay attention to, it's been a while since we've had point slope formula, but notice that the h is negative in the equation and the k is positive. Like in the quadratic formula where it said negative b plus or minus the square root of b squared, that negative b really meant the opposite of b. We have that same thing going on right here. So when we pull out the h, we are going to have to use the opposite sign. If it looks positive, we will write it down as a negative. If it looks negative, we will write it down as a positive.
Shane, how many of those you got?
She
Don't
says she
worry
drinks a
about
lot of liquids every day.
Are we okay there?
Yeah.
We have all of our terminology down.
Yes.
Yes, ma'am.
What about the one?
We're going to get to it.
Like a bird. It's like Lottie.
I know, correct.
Okay, Haley?
Yeah. Oh.
Who said that?
H is going to change the horizontal movement.
Is that why it's called H?
Good question. I don't know. It makes sense that it would be, but the problem is that K changes our vertical, and that's not a V. If H is positive, we are going to move right. And if it's negative, we'll move left, right? That makes sense for what it is. We'll finish after lunch.